Parasuraman, can we start now? Mr. Parasuraman?
Sure, sir. Sure, sir. Yes.
Very good morning to one and all. Today, we are in the 5th day of AICT Atal FDP on Internet of Things. It gives me immense pleasure in inviting today's resource person, B. Parasuraman, Principal Consultant, Hexaware Technologies, Chennai. I would like to read out a very short profile of today's speaker. He is a senior architect, applications, modernizations, Chennai, India. He is also an architect in the apps modernization group, focusing on multiple discovery, assessment, migrations, and modernization. Over 18 years of experience in providing solutions and managing the programs. He worked with IT majors like iSoft, Virtusa, Wipro, CSE, which is now DXC Technologies. He also worked with customers from multiple geographics like US, UK, Asia, and Africa, especially in healthcare and finance domain, for the prestigious clients like Zurich Insurance and NHS of UK, Thomson of US, ESIC of India, and NWH of Africa. He also have a rich experience in enterprise architecture and managerial space of modernization and migration programs. Best of all, and more to say, he is our alumni of our MCA department. So with this, I am extremely happy to invite Mr. Parasuraman Balasubramaniam for the technical session 1 to speak in the title of Application and Enterprise Architecture. Thank you.
Thank you, Anna. Anna, can I start now?
Yes.
Oh, thank you, Anna. Okay, good morning to all the participants. Okay, let me share my presentation, then I'll continue in my flow. I think, let me share my screen. Just give me a moment, please. Okay, I shared my screen now. Please, Anna, could you confirm whether you are able to see my screen?
Yes, it's visible.
Oh, thank you, Anna. Thank you. Okay, those who all new to Ramakrishna Mission Vidyalaya, you may wonder that I'm addressing Saktivel sir as Anna. It's a uniqueness of our institution. As Anna said, I belongs to Ramakrishna Mission Vidyalaya, and this is an opportunity to meet you all in a nice morning. Thanks for the opportunity and all this of this event. Okay, I just want to say a couple of words before starting. Just give me a moment. Video's on. You're crossing. Okay. Sorry for that. So just to say a couple of words about
If you want, you can close
it's from poet Kabir. Sorry,
if you want, you can close your video. Camera.
Could you,
If you want, you can close your camera.
No problem.
Okay.
Yes, while presenting, while starting the session, I'll just want to say a few things, and then I'll switch it off now.
You can.
Basically, yeah, I would like to refer a couple of lines from poet Kabir. Kabir and his friend were walking, and they saw a pool of water and some lotus plants on that. And Kabir asks his friend, why this, how this lotus flower blossoms every day. And then his friend replies, sun comes when it feels the sunshine, blossoms. Kabir said no. And he asked, his friend replied again, saying, no, there is a water on which the plant is there. So because of the chillness, it blossoms when the sun comes. Kabir said no. And Kabir says, the plant has its root on the earth. So that is the reason whenever the sun comes, it blossoms. And if the root is not there on the earth, if there is no root, the flower will not blossom. So with all my gratitude and appreciation, so I'm connected with my root, that is my professors and all my lecturers, and I'm very much thankful for that. So with that, having said that, let us get into today's session. Just give me a moment, let me stop the camera. Okay. Am I audible? Is clear?
Yes.
Thank you. Thank you. So today's topic, we are going to see a couple of things. One is about and its importance and how we are arriving in architecture. Probably this is going to be kind of a boring session as well, because some of you are already familiar what is the process and how we arrive this, and but what I'm going to discuss today is the practically what we are doing in the industry, and how we are implementing, how we are arriving the architecture, and how we take it forward, right? And that is the agenda. This agenda basically we cover a few bullet points what I have mentioned. One is the application architecture and underlying infrastructure. What kind of infrastructure we need to have to come up with an architecture, whether it is a application or enterprise. How are we going to classify that? What are the components required in the infrastructure perspective, and what exactly the enterprise architecture? It is kind of probably I would say we will drill down from 30,000 feet, and we'll see different components available, and what are all the aspects we need to cover. What is the importance of having an enterprise architecture? How that will fit into the next topic, the cloud computing. And then what we are going to do is kind of we are going to discuss a couple of scenarios, especially with the cloud-based components like platform components, cloud platform components. We are trying to come up with an architecture for a couple of scenarios. So this is the agenda today. So it's basically to think in terms of completely architectural concerns, and what I'm trying to do is I'll try to come up from the generation 1 language, how the language and how the architecture paradigm shift has happened, and what is there in cloud environment today. So this is an agenda. And okay, who am I? As Anna mentioned, Saktivel Anna mentioned, with around 20 years of experience. Initially, I was in the hardware networking side. I was doing some cabling, crimping, and managing some networks. That was my role in my early days. And I started coding in assembly with C, and also a language called Clipper. And then slowly moved into application domain. Right now, helping the organizations in their digital transformation, and being a consultant for cloud environment, especially Azure and AWS cloud platform. And also a kind of a hobby. I'm also a licensed amateur radio station operator. I have given the address to reach me. My mail ID is there. My radio call sign is there. So you can reach me in either way. Okay, this is a detailed agenda. Sections will discuss application architecture and then infrastructure, and how programming construct has evolved, and then enterprise we will cover. The next session, what we are trying to do is targeting the cloud computing and cloud infrastructure and architecting and hands-on scenarios. So why I have mentioned all these again, it seems like I'm repeating, but the moment you have this slide deck in your hands, you can go through this. In this deck, I have used the diagrams as much as possible. Some of the places I have kept full single slide with full of text alone. That I leave for your reading. We will move with the diagram and explanation. And please raise your questions whenever you have any query. We will address then and there. That would be useful. Probably Anna can help in that. Saktivel Anna can help in that. Okay. I also see a lot of people joining from other parts of India. So normally Anna means it's elder brother. So this is our relationship with our professors and students. Okay, so with that, let's move to next slide. Okay, applications, softwares. So there are major types in the software or application. We'll say commercially off this shelf. So we see some of the applications or software available in the market. We will purchase that software to our organization or enterprise requirement. It depends on what kind of a domain we are in and what kind of a software we are looking for. It ranges from very small application to a bigger application or the enterprise level application. Even now, many platforms are available, enterprise level platforms, and there are products we heard a long back. ERP around 25 years back itself, we started hearing and orange shelf things. It targets a particular domain, but it supports the complete enterprise with multiple department or multiple workflow orchestration with that. SAP is another product. So these are all, these comes under cards category as well, also the enterprise application, right? So the magnitude of the application defines at what level we fit the particular software, whether it's a cards category or the enterprise application. In between, we have two different things. One is the custom. Normally, the custom applications are the one which tailor-made, I would say. It's a customized component, like how we are the bigger automobile industry can say, the big people like Audi or Benz, or even Lexus. They offer the flexibility to their clients or their customers to customize their car, how they want to have the interior cabin, they can customize. So it is similar to that. According to our environment according to our need and domain. We customize the application through, we use different languages. For example, earlier we used C, C++, and then we moved right now we have SPA, single page applications. We'll go with most of the things are Angular and JavaScript based coding style nowadays we follow. So the custom applications are that, and then we'll jump into the line of business application. These are specific to a particular domain and particular business scenario. For example, we'll say Office 365 or SharePoint. We can create a line of business applications or in Lotus Notes. Let's take it. It's a bit legacy, but still, so many people are using across the globe Lotus Notes applications, right? So these are all example for the line of business application. And then, okay, specific purpose, some introductory. I have kept education industry as an example because this example will drill down more, and we'll discuss about how this particular domain functions. What are all the different kind of a requirement we capture there, right? That is the next point. Let's say functioning of an university. University, university's functions, it's just very broad in nature. It governs the affiliated colleges. It also conducts various examinations, and it also takes care of their associated professors and some cultural activities, some club activities, various departments issuing degrees, right? So there are so many functional aspects available from the university. Similarly, there are something called the non-functional aspects. When we start looking an application or a software, when we try to come up with the software, we need to see both. These are the requirement basically in functional and non-functional thing. Functional we discussed. Non-functional are nothing but the basic, the construct of that particular software, how that software should run, who is going to access the software and or the application, and who is from where they are going to access, what kind of a data they are going to manipulate, where they are going to store the data, and what kind of a retrieval mechanism we have in case of any emergency or disaster. So these are, and how the security is being maintained. So these are all the various non-functional aspects of an application or software that we are going to see in detail down the line. And as I mentioned earlier, there are two different kind of a paradigm shift have happened. One is the architecture, the software architecture evolved enormously from the initial days to now. In the cloud, we are in we are using cutting edge technologies right now. So, and the programming aspect, whenever it is not only the architecture evolution, the programs or the languages and their construct need to support the architecture, so that we'll have the complete benefit out of the software or the application. What has happened in these two space, that is what we are going to explore down the line in the upcoming slides. Any questions so far? So this is these two slides would have given a kind of an agenda. Any questions? Can I move to next? Okay, I'll take the silence as an acceptance. I'll move to next slide.
Parasuraman, please.
Yes, Anna, please. Yes, Anna, please.
Yes, now I made all the participants can unmute their mic and speak. If they have any questions in the middle, they can raise their questions. Okay.
Perfect. Thank you, Anna. Thank you.
Okay.
Yeah. Let us have it as an interactive session as well. I'm perfectly okay. So let's move to next slide. Okay, this slide has a little bit of information. You can see at the top we have a definition of an architecture. What is architecture? This is a commonsensical way of choosing right components manner. This word, there are a couple of words important here. One is the commonsensical and then appropriate. It's basically, architecture is not a big rocket science. It's a very simple stuff with a common sense what we are doing. And the appropriate, the word actually gives a lot of meaning here. It kind of, optimal, we can say it's a optimal manner or the right choice, and placing in a particular order to give more benefits, extracting more benefit out of how we are arranging the components. So these are all the meanings we can have for the word appropriate here. And to represent any architecture or any functionality, we have something called a 4+1 model, concurrent views. This concurrency, the concurrent view, that is also an important aspect here, because we are dealing with different scenarios. If you see the left-hand side diagram, in the middle we can see scenarios. Scenarios are nothing but use cases or the user functionality. Each functionality or can be represented in these 4 different ways. What kind of a, how are we going to denote that functionality with, its process, that we capture in different aspects. One is the logical view, which talks about how we are layering or what are all the different components that technical components interact with upstream and downstream components. That is what we capture normally in the logical view. So it clearly gives an indication, or it clearly represents how the interaction between different layers of components happens within an application architecture with their upstream and downstream components. Let's say if we click save button in a screen, how the data travels between the database and the user screen. What are the different layers it crosses? It can cross application layer or business layer or some database layer, and then it finally get persisted in the database. So this is what we represent in the logical view. And the process view basically it gives what kind of a functionality we are applying, what kind of a functionality we are processing, and who are all the different stakeholders involved in that particular process. So that we will capture in the process view. Basically, we'll see the transactions lifespan. Again, I'm saying we will see the transactions lifespan or the object's lifespan. In each layer, for example, if you are instantiating an object, how long that object will live in that particular layer, how long it will be there in the memory, in our physical memory, that is RAM, how long the object will exist in the RAM, and when the object will get garbage collected, or we'll say we will deallocate that object from the memory. So this is kind of internal. A little bit I'll go in depth as well, a little bit deeper. If any questions arise, please let me know. And the development view is nothing but how we group, or how we club the different functionalities in the project view. For example, there can be multiple classes, there can be multiple functions available in a particular DLL, I would say. I'll take an example
Sir,
of
excuse me, sir. Sorry for the interruption.
Of ASP. Yes, please. No problem, please.
Sir, the slide that you are currently showing in the box, you have like diagrams, class diagram, object diagram, etc. So all these words which actually comes under this unified modeling language, UML.
Correct.
Is it so, sir?
Absolutely, you're right.
And whether you can use this software tools, MS Visio, Visual Studios.
Yeah.
Basically, in some embedded system designs, people used to use this UML language. Thank you, sir.
UML, right?
Yes, sir.
You are welcome. Yeah. So this, okay. With that information, with the development view, basically, I was mentioning about how we group the functionalities in a project. The project can be an exe project. For example, it can produce an exe file as an outcome, or it can produce a DLL file as an outcome, right? In an example of our ASP.NET web applications, or any other previous applications as well. Probably in the world of C or C++, we will produce a lot of header files. We'll produce exe files, right? So header files will be used for the reference. And similarly here in the .NET world, Microsoft world, or in the Java world, we'll have a jar files. .NET, we have DLL files. So these components, how we are going to group, how this is the development view is the place where we will define how many functionalities should be clubbed together or encapsulated in a particular DLL, which is a kind of a deployment component, right? So where we are going to position the component, that is what we need to initially segregate that, and we need to structure our development project accordingly. That is what the development view gives, right? And the physical view is nothing but our components, deployable components, and it also associated to the underlying infrastructure. So for example, if it is a 3-tier architecture, we will say what component we need to keep in the UI tier, and what component we need to keep in the application tier, and what component we need to keep in the database tier, right? So this grouping need to happen. This vision should be there from the initial stage itself. That should evolve from the stage of development. We need to have that, and then it will traverse throughout the development lifecycle and until the implementation and until the deployment. So this is what these two diagrams, these two boxes, development view and the physical view, represents. Let us move to the right hand side now. As we discussed, the logical view, which is basically upstream and downstream interaction, what we are going to pass from the upstream and downstream, it's nothing but data in the form of an object, right? So the object model and the designs are nothing but the one which we concentrate more in the logical view. We use class diagram and object diagram in mostly in the logical view, in the layerings, right? And then if you see the process view, I mentioned the process and the sequence, basically how the transaction happens, what are all the different functional process it has to undergo to perform a particular transaction or to fulfill a particular business functionality, right? That is what we capture in the process view. We use use case diagram, or not exactly use case diagram, we predominantly use a sequence diagram to capture the process flow, and we can even use activity diagram to capture the activities performed, and we have a state chart diagram to represent the different states the business process has, right? So all these diagrams we will use in the process view. In the implementation view and deployment view, predominantly we cover the the deployment diagram and component diagram in these two segments. If you can see, there are two words mentioned here: conceptual and physical. The conceptual is basically these two are conceptual, and it's all about the process and logical stuff. Right hand side, you can see they are the physical. We can see the outcome, and they are the deployable piece of information, objects or the exe or some files you will get as a deployable component. This is about the architecture and how we represent it. Even in our IoT environment or any database oriented environment, this is what we are going to do. We'll capture the process. In our IoT environment, normally the process will involve a lot of components, collecting data from the real-time environment using various sensors and parameters, and it should undergo a lot of business process and calculations and everything, and we'll capture that using the process view. And the deployment view is nothing but our instruments and our apparatus and our logics and our core algo and all those components and the database. These are all we'll be capturing in this physical section. Any questions? Because this is, I'll take a little bit of more times in important slides. Otherwise, I feel we can go through a little bit faster, because
Yes.
we have still 55 minutes to 54 minutes, yeah, for the first session. Okay. Any questions, please? Okay, I'll take this silence. Let me move. Okay, this is the architecture. We are seeing different type of architecture. Everybody knows what is a client server or two-tier architecture. Um, we have a machine as a client machine, and we have server. Here the server represents the database server. But now what we are going to discuss is hello, am I audible? Hello.
Yes, sir. Yes, sir. Audible. Audible.
Oh, yeah. Thank you. Thank you. Is my screen visible?
So no, sir. No,
Okay.
sir. Your screen is not actually visible.
Okay. I just shared it again.
It is visible now.
Yeah. Thank you. Thank you. Okay. So this, I was discussing about, I was talking about this particular client server. So this client server everybody knows, but our perspective here is towards architecture. What kind of, what are the parameters we consider to define the client server, or the next slide I'm going to discuss about the three-tier architecture. This is about how are we going to place the load. When I talk about load, it is something like where exactly the functionality happens, where exactly the most of the resources are being utilized. So when I say resources, where exactly, in which place, whether it is a client side or in the server side, the most of the RAM or operating systems resources, or IO, or what can, you can have any resources, where exactly we will have maximum utilization of resources. That is the view we need to have when we discuss about the architecture. So it is in, this is about infrastructure perspective, but from the application perspective, where exactly we need to keep our logic, business logic, the execution part, what we are doing in the client side, what we are doing in the server side. We might have seen a lot of softwares in probably 20 years back. We used the full potential of the database servers. We have written more queries, stored procedures, triggers, and sequence, and so many database concepts we used to have to keep our logics. Right. So we very rarely used our front end or the client, I would say. In the screen, we capture the data, and then we'll simply pass the data to the server, right? Where in server, we'll perform all kind of validations and we'll save the data. This is about the two-tier architecture. So the load or the most of the work happened in the server side, not on the client side. This is the two-tier environment. And we slowly moved into the latest technologies. Especially, we started using C or C++, and even with C++, we can have two-tier applications, right? Or the client-server applications in an object-oriented environment as well. It is in that case we started, using some amount of business logics at the client side as well, right? There are two different terminologies here. One is the layered architecture and tier architecture. So what is the difference between layer and tier? So the layers are nothing but a logical grouping, but the tiers are nothing but a physical separation. If you see here, we see two different boxes. The server is the one, and the client machines are the another segment. So these are all the tier 1, and this is a tier 2. This is a two-tier architecture. Right? We can have multiple layers even in this also. We can have a business layer, we can have a data access layer, we can have a UI layer, we can have more than 3 layers also, but it still remains a two-tier architecture, because the tier is nothing but with it is mostly the infrastructure and the deployment oriented. Where we are going to deploy, in which machine we are going to deploy, that represents the tier. Layers are logical grouping. Having said, let us move to the next slide. This is the three-tier architecture. This three-tier architecture, the bottommost is the browser. The end user connects to the web server, which is a tier 1. We can say front end, and then application server, and then database server. Application server, there are two possibilities. You can have normal component like a DLL component or any jar files we can have, and we can communicate with those components from our web server. And in a .NET world, we use something called remoting, and in the Java world, we call something called RMI, remote method invocation. So this app server components, basically, this is the place we we keep all our business logic. The web server is the place where we capture the data, and we'll have all our painting, tinkering, all our UI stuffs will be there with our JavaScript functionalities, and HTML and CSS files will be there, and some amount of client-side validations will happen in the web browser and using the JavaScript, right? And then the full business logic and the functionalities, and that happens in the application server. The database server is should be used, I would repeat, should be used to keep only the data persisted. But even in the three-tier architecture, most of the time, we have seen a lot of applications have the stored procedures, the business logic in their stored procedures. Simply, they will use the app server to do a small validation and to pass the information to database. It's a kind of a trade-off. We need to keep the performance also in mind. Normally, it's something like this. Whenever we do operations in the database server, we feel it is more performance oriented. We'll see more potential. We have more resources we have in the server, and so it looked like what I'm saying is around 10 to 15 years back. This was the scenario actually. We had a lot of resources available in the database server, but now the trend has changed. We have completely scaling environment in the middle tier as well. We have virtual environment. We will discuss about that down the line. So the business logic can be kept in the app server itself, right? So in the app server, we discussed about remoting and RMI, but there is something called services, which is a huge topic. Again, the services are nothing but exposing a functionality over the internet or any other network, so that others can consume it, others can discover it, basically. there is something called service discoverability. So we can discover the service. You can publish the service over the network, and others can consume it just by seeing the signature. That is the power of services, web services, right? So the services are nothing but it encompasses the business functionality. When we have multiple services together as a kind of a string, as a series of services will fulfill a particular business functionality. There are different patterns available, but let us not get into that now. What we need to remember is we can have different ways of keeping business logic in the middle tier. That is application tier. The load is distributed here. I said the validation happened in the front end, and some business logic, business sequencing, business process orchestration. That is the word we use in the service-oriented architecture, right? So we need to orchestrate the business process. It is nothing but arranging the services in particular order, right? So we see the music orchestra, right? So there is a person called arranger. There is an orchestrator. They basically keep all different instruments. If you see the orchestra, symphony orchestra, there will be different sections, and there is an orchestrator, there is a arranger. They will do all the keeping the instruments in particular order so that we'll hear the good music. Similarly, this is an art actually. This business process sequencing, and how optimally we place uh, the components so that we'll get a more performance oriented and optimized output from our software. This is an art really, right? So we'll go to next. This is an enterprise level view. We have entire application. We have multiple servers involved here and multiple layers involved here. The data can flow from anywhere. We will spend some time here. See business application. This is what we mentioned, the line of business applications in our first slide when we discussed about applications. And we have down below, you can see different web portals. Web portals we have, web services we have, they both are exposed over web internet. So that is why we kept the globe over there. And we have a business process, components, and we have a Java servers, MQ series. This is nothing but message queuing, right? Message queuing is another concept. Let us discuss about that as well now itself, right? We will save some time in our second session. The message queuing is nothing but, it is something like we all know the dabbawalas, right? The Mumbai dabbawalas. I will consider them as a kind of a message queue. It's basically from our home, we will give the lunch box to the dabbawala. The person takes that and he goes to different places and he keep that in their station. The box would be kept in a particular basket. There will be a coding, uh, to where exactly this particular box need to go from north part of Mumbai to south part of Mumbai, right? So all these are nothing but asynchronous transaction. We will not know whether the box has reached the destination or not, right? We need to wait for a couple of hours to get a phone call from our family member after their lunch, or during their lunch. They'll say they will give a phone call and say, I received the box, right? So in between there is no, it is not a live communication. It is a asynchronous. It is not a synchronized communication. Whereas in synchronized communication, we will get the feedback immediately at the end of when we click the save button. After the data is getting persisted, we will get our feedback immediately. The database will return a value, right? But here in this asynchronous call, we will not get any, it is just fire and forget. We will just publish it and we will forget about that. This queues are nothing but the carrier of our tiffin carrier. Okay, these are all the carrier, actually, the data carrier, the queues. We have different mechanisms in queues. We have something called the dead queues. We have something called the poison queues. We will do retry. If we are not getting any messages, we will repost the message in a queue, right? So it is something like if the if the dabbawala reaches the railway station for a couple of minutes with couple of minutes delay, probably he would have missed a first local train, right? So he need to wait for another train to come. Again, he will push the box into the next train, which is nothing but retrying. He missed the first opportunity, so he's pushing again he's trying in the second opportunity and pushing the data into the queue. Then it reaches the the database or the next business functionality that will take and process, they manipulate the data. This is the asynchronous communication with message queues, right? There are message queue component available in the cloud platform as well. So that is why I spent some time on this. And this ESB, this is the service bus, right? This message queues are connected with the service bus. This service bus are like, you can think about the unit trains of Mumbai, right? It carries it carries the data from one place to another place. It can be used by anybody, right? So this is about the enterprise service bus. It does a lot of functionalities. ESP supports a lot of functionalities. It transfers the data. It also transport the data. It supports a lot of protocols. It supports a lot of adapters to accommodate a protocol. The simple example for an ESB kind of an application is a BizTalk application, we can say. It gives a lot of adapters. It supports a lot of protocols. It supports a lot of endpoints. It supports different architectures, right? It supports a lot of databases. You can connect other equipment or gadgets with that using some standards, right? It also supports encryption for the security. So this is about enterprise service bus. All an enterprise, let's say Tata Steel, right? So the Tata Steel may have multiple source of information, multiple uh, gadgets or environment, and a lot of sensors will be there. A lot of IoT components will be there. So this ESP should be capable enough to support all those components and all those functional aspects, right? So this is about enterprise architecture. Any questions in this slide? So if you understand this clearly, then it will be more easier to go with the cloud. Any questions, please? Okay. Thank you.
Audience, any questions?
Let's move. Either I'm more clear in explaining, or I'm not audible.
Sir, I have a query.
Please go ahead.
Sir, why it is called loosely coupled architecture?
Okay, excellent. These loosely coupled architecture, if you observe this, there are two things. Here we have one layer, and we have below also one layer. And as I mentioned, it follows the standard, right? It follows the standard. I would go with an example for a loosely coupled architecture. In a university example, let's say in university, there are different, right? In many colleges, the students are studying. The colleges which follow the standard of syllabus, right? The university. So if the college follow the standard syllabus of university, right? If a student studies in one college, after first year, if he wants to go to another college, there is no problem. He can still go and he can continue with his second year studies or third year studies, because the syllabus is going to be same, right? Because there is a standard. This loosely coupled is similar to that. We can
Okay.
It's a kind of a plug and play, right?
Okay.
So it follows a standard. We know a pattern. We know what kind of data is being exchanged. We follow a particular protocol. Let's say web services, right? Web services are using SOAP protocol, or underlying, if you see, it uses HTTP.
Okay.
HTTP has its own functionalities like get, post, and put and delete functionalities, right? So these functionalities are standard functionalities of HTTP protocol. So whatever functionality you have, business functionality you have, it has to adhere the core protocol principles, right? So we can still remove that, and we can plug in another component, or we can easily modify that as long as it keeps the same protocol or same standards in place. That is why we call it as a modular. And if you see this diagram at enterprise level, if you don't want a particular database, right? For example, if you are using a DB2 in a mainframe
Okay.
environment, tomorrow you want to replace that with the latest MongoDB or any other software, right? Any other database technology. You simply pull out and you insert another new technology and connect it with the ESB. It will support.
Okay.
That
Means
is
you
why,
you want to say that it can be modified according to our need.
absolutely,
Okay. Okay. Okay, sir.
absolutely.
Okay. Okay. Thank you. Thank you, sir.
Yeah, welcome. So this is the advantage of having an ESB and a loosely coupled architecture. Uh, okay. Any more questions? Okay, let's move to next. This is about architecture. What is architecture? What is design? Let's quickly go through this. Architecture talks about the application's structure and its purpose and its strategy. It is basically towards abstraction. We will abstract all the all our I would say, like all our concepts, all our requirements, and it's kind of a coming up with the blueprints. Normally we have a blueprint for a blueprint plan for our building construction. It is similar to that. We'll discuss about all the application structure. When I say structure, you can think about the different tiers vertically, right? Let me go back. This is a vertical, right? So we have a database server. This is vertical. So this is a structure. So we'll discuss about the structure over here and the strategy. What kind of a tool we need to select, what kind of a component, and where we need to keep the functionality. All these are nothing but the strategies, right? And when we talk about the design, which is nothing but low level in nature, we'll say how an object needs to be constructed, and how the object should interact with other upstream and downstream layers, like that. So this is I would like to mention about GOF, Gang of 4 patterns. Uh, Normally, when we talk about the design, we'll talk about the design patterns, right? We have a different construction and behavioral. There are different patterns available. So everybody knows about the singleton pattern, right? So only one instance can exist. This is about the design. The next important aspect with respect to non-functional requirement, with respect to architecture, is non-functional requirement. This is the core. We need to spend some time over here. This is about nothing but discussing the security, scalability, availability, performance, maintainability, and disaster recovery, and many more. I just kept 6 major points here. There are more non-functional requirements are there. For example, I have not kept any compliance or policies to be adhered by the system. For example, in European Union, normally, especially the financial sectors, right? As Saab mentioned, I was with the Zurich Insurance. Um, okay, so we handled we handled the data of great royal monarchy, I would say. So it started with a lot of non-functional requirements. The moment I joined in the project, I need to get a certificate from my local police station that I'm very clear. I don't have any cases pending against me. So that is a one kind of a requirement, non-functional requirement. They will scrutinize because I'm going to deal with the data. And some places the data is the rule, the state of law, the law of particular state. I'm sorry, the law of particular state will demand that only the example again, European Union. The European Union says it expects only the European Union citizens should be able to access particular data, classified data. So even though we are skilled, we cannot go and touch. Even if we go there, we should not be able to touch that particular data. These are all non-functional requirements, right? This comes under security again, but different kind of a security, not with respect to our application design or anything. This is offline. We need to do all these things. With respect to data center security, there are a lot of standards available. For example, in a healthcare industry, we have something called HIPAA. It demands a lot of constraints to be fulfilled by the even in the from the data centers perspective, where the data needs to be stored, how it has to be accessed, how long it has to be retained, how it has to be archived, what kind of encryption mechanism we need to have in the database. From the application point of view, when we talk about I'll quickly go through this and then I'll take questions. When we talk about the security, it starts from the physical security. From the physical security, and it starts with the authentication, whether the person is the right person, whether the right guy gets into our system, right? So that is the authentication. The next level is whether the person has privilege to access our university. We can go and meet our colleagues. If it is a student, we can go and meet the student. We can go to if fellow professors, we can go and meet. But we cannot get into the principals or any other registrars or the vice chancellor's cabin immediately. We cannot go just like that. We need to we need to have a permission, right? So there comes something called the role. What role we play in the system. So we will have privilege based on the role, so that we'll be exposed to the functionalities according to our privileges, right? So this also comes under the security. And when we talk about the data, it's huge. Data during the travel from front end to middle tier, from middle tier to database. When the data travels, what kind of a security we provide, whether we encrypt the data or we use any SSL in between, secured socket layer, right? We say for encryption, say, using key, using a key, we'll encrypt. Again, that also, what kind of a key we are going to use, what kind of a certificates we will use. So that also matter. It should be very strong enough so that nobody will compromise. We will compromise that. So it is more secured in terms of, and again, when the data is at rest, what kind of how are we going to protect the data? Whether we are going to encrypt it, where we'll keep the key for the encryption. In a physical data center, even we can have a key in our pen drive and we can insert in the database server. But in cloud environment, we cannot have that luxury of inserting a pen drive, right, with our own key. So what kind of a mechanism we use? That all we'll discuss when we discuss about a cloud. And when we talk about the scalability, it is nothing but today my application attracts 100 users per day. Tomorrow some magic has happened. 1 lakh people are hitting my website or web server. My application with the available resources. For example, I would have provisioned 8 GB RAM or 4 GB RAM with very limited processor capacity, right? So the application may not be able to support 1 lakh customer or 1 lakh people, right? What we need to do, we need to expand it. We need to expand the availability of resources so that the application is available to our customers. This expansion is called scaling. We have two different kinds of scaling here. One is vertical scaling, another one is horizontal scaling. In a vertical scaling, we will open our server, physical server. We will add one more strip of RAM. If there is an already 8 GB of RAM is available, we will have another slot. We will insert another 8 GB of RAM, so that it will become 16 GB of primary memory. The application will perform little better, right? But this is vertical scaling. This is whatever improvement we are doing, we are trying to do in a single place, right? And next is a horizontal scaling. It is nothing but simply adding one more physical box itself. Horizontally, we are scaling. When I say physical box, it is also with the application instance. We are creating more application instance, right? But in a vertical scaling, we try to keep the same instance, but we try to add more hardware resources. Right? So that is the difference between vertical and horizontal scaling. In cloud, the same concept is available, but in a different terminology we will use. We will see down the line. And the availability. When we talk about the availability, it is nothing but the application should fulfill the expectation. Nowadays, everybody uses mobile phones, right? We have our bank application in our mobile app, through our mobile app. What will happen if our, for example, if you are transferring money, 10,000 rupees, I'm transferring to my friend. Sometimes we feel the, you might have felt the pain, like transaction failed, or if we used our credit card, the money would have got debited from our account, but the actual recipient might have not received the money, right? This is the problem. Some issue has happened in between. Some service might have failed, right? So in that scenario, this particular terminology comes in picture, the availability, right? We should ensure that our application, our services is running and available for consumption 24/7, right? Or 99.99% my system is up and running, right? So this is an example. Amazon gives 99.99. Totally, you will have 11 nines of availability. Just think about it. Just we will have a few seconds of failure in a year. Throughout an year, we will have only few seconds of failure. We will not have time. We will not have any disturbance in between. That is the amount of high availability that Amazon provides. Amazon Web Services, right? AWS environment, cloud environment, PaaS components provide. This SLAs are nothing but service level agreement. This is a kind of a contract between the customer and the service provider. As I mentioned, Amazon says, I'll give you a service which is 99.99, 11 nines availability, right? So that is the agreement. And the performance is another factor. It is availability is one aspect, and performance is like how fast my transaction gets completed. It's nothing but latency. Normally we might have seen the latency, right? We would have seen our operating system also. We discuss about latency, and our application software engineering also will discuss about the latency. How long it will take for a transaction to get, to process the data, and also to come back and give the response to the end user. We need to provide the meaningful reply to the end user. So then only we'll consider one transaction gets completed, right? So the performance is nothing but it talks about the latency. We had a client. We worked for a Singapore client, and it was Singapore government. So they were expecting the latency of 1 second or 2 seconds, like that. And the volume of in another case, with another client, the volume of transaction happens in a day is 15 million. 15 million, I would say 1.5 crores of transaction in a day. Just we need to, if you calculate, it will come around per second around 7, 8 or 10 transaction. So our application should be capable enough to support that much of transaction, right? It all depends upon many factors. As I mentioned, the right capacity we need to have, right capacity, right bandwidth we need to have in our network, and we should have chosen the right set of algorithm and right object structure we would have selected. So all these concepts from our coding, performance oriented programming, it's a separate, it's an art by itself. How efficiently I think performance engineering, you would have frequency analysis and all will come in. We would have studied, I remember the days, the frequency, how in a loop, what is the frequency of particular loop, how efficiently the particular snippet functions. So all those things we need to consider, and it also we also need to think about the database side, how it is uh, how just give me a moment, please. I'm sorry, just give me a moment. I'll be back. Urgent phone call. So that was the reason I just went off. Sorry for that inconvenience. We were discussing about the performance. So it starts from, it has multiple angle from the source code and from the environment and from the database side, how our data is being designed, the data is being modeled, what kind of indexing we follow, what kind of paging within the database server, how the memory paging happens. So all these aspects are considered when we discuss about the performance. And the maintainability, again, maintainability is nothing but, I just mentioned the word release cycles. It's nothing but, it also talks about the modularity, how modular our application is, so that it can be easily maintained and we can have multiple enhancement on top of the existing application. That is what we call it as a release cycles. How frequent releases, for example, any the retail market platform, like any retail portals, they will have multiple releases. They will have multiple offers, festival offers, for every day they will have something. They will introduce new functionality. So the application should be modular enough and should be easily maintainable with respect to the source code, or it is componentization. How what kind of just remember, we discussed about keeping different functional modules in particular application deployable component. Many what functionality goes where, that is what the core of maintainability, right? And then I just mentioned about operations. It is nothing but monitoring the environment and collecting metrics, so that we will use the metrics to come up with the optimization. For optimization purpose, we can use the metrics. I don't want to spend more resources for a less demanding environment. If the functionality is very less, the demand is very less, I don't want to have a huge amount of RAM or anything, right? So the disaster recovery is the another piece. As I mentioned, let's say our same university scenario, we keep all our mark sheets or our degree certificates. If even if we miss something, we can go to university and we can apply for duplicate. So they should retain their our internal data in the university premises. So the data center should be capable enough to have the backup in case of any disaster. They should be able to reproduce the same amount of data. There are two things I have mentioned, RPO and RTO. RPO is recovery point objective. For example, let's say something has happened in a particular university, and the university would have conducted, let's say if it is in a even semester, they might have conducted first a couple of internal examinations, right? So when something has happened, the university should be able to reproduce all the odd semesters mark sheets, right? So that is called RPO. At up to what time, for example, whether I am able to cover till last 10, right, or till last month or semester. That is the point. Okay, I lost only 10 minutes transaction, I lost only 2 months data. That is fine, but we could able to retrieve something. RTO, recovery time objective, is how soon I can retrieve it. Still, I should be able to retrieve only last semester information, but I can retrieve that information within a day. This within a day is nothing but RTO, recovery time objective. How soon I can bounce back, how soon I can retrieve the data. That is what RTO is, right? So any questions or any queries, any thoughts in this slide? Okay, let's move faster a little bit. Okay, infrastructure, we'll discuss about the different components here. We know, I just grouped, there are 4 different components. The core components are nothing but we should have network and compute, the processors, and then we should have memory and storage. Normally, this we can find in our physical computer, single standalone PC itself, right? Without except network. Probably we may have a network card, interface card, NIC card in that. But except that, all the compute, memory, and storage we have in our PCs. When we discuss about the network, we have the communication components also in place. We have load balancers, routers, hubs, switch, and we have gateways in place. And we also have security-oriented components like firewalls, and some monitoring components also we have. And there is something called CMDB. CMDB is nothing but the complete the portfolio of our infrastructure data will be there. The entire stack of data will be maintained in the CMDB. That is called a configuration management database. So that is also, we have CMDB will have applications information as well. Okay, with that, let's move to next slide. This is important. This is nothing but the DMZ, demilitarized zone. Demilitarized zone is the more secured way of provisioning our infrastructure or having our application in place. For example, when the user enters their credentials from the browser or their laptop, it goes through network. It goes via a network. In this case, in our diagram, we have kept internet. This goes inside, and there is a firewall in between. It validates whether the person is the right person or not. Only the authorized persons would be allowed to get into the firewall. Right here, we have our application, on the servers, and the backside also we have something, another firewall. The section in between 2 different firewalls, or the that particular portion, is called the demilitarized zone. We are securing from both the ends, right? Just remember, I was discussing about upstream and downstream applications, or the connecting upstream and downstream of data. So this is nothing but this is our upstream and this is our downstream. Intranet is nothing but our enterprise level information. When the person getting inside to our network, the person has to be authorized, and he has to cross first layer of security, and then some amount of information will be there, and then second layer of security, then we'll have our internal systems. For example, suppose somebody compromised internal systems, and that person wants to access this particular piece of information. Again, he has to compromise this particular firewall, then only he can get into this particular area, right? Both the ends, we have our security policies in place, so that there won't be any attack from both the ends. This is called demilitarized zone. The right hand side diagram, you can see this is a sample. This is from SAP. In fact, this is from SAP. This is a 3-tier architecture represented in an infrastructure way. There are two different entry points. You can see the thin client here. There we have a web browser based application running. We can use mobile for smartphones or workstation or laptop. We connect with the the application hosted on a web server, and then we'll get into the web services, right? And here we have another entry point, the bottom left, rich client. We have a rich client application, probably a Windows application, let's say. If anybody who's playing with the share market will understand this concept very clearly. All the providers, the share brokers, will provide two different interfaces, or many interfaces. Of course, they will provide mobile phone based application, mobile app, and they will provide website based interfaces, and they'll also provide a actual application we can install in our PCs, right? That is called a thick client. So based on their entry point, the provisioning of application will happen. This web client will first getting into the firewall, this particular firewall, and it gets into the web servers. These web servers, and then to reach the application servers, it has to cross another firewall here. This web servers are accessible only by these thin client applications, these web users. But this firewall can take call from the rich client as well as the web servers, both. You can consider these rich clients or the internal organization's internal employees. For example, a student want to access their mark sheet, or student's parent want to access their mark sheet. They will use some credential to log in through the web server. They can get into the application servers. But when a university staff logs in, he can directly log in. He doesn't need to use these web servers. He can directly log in using the rich client into the application directly from using this particular firewall, right? So based on our role, based on our authentication, all these provisioning need to be made. And from application, we have another firewall so that the data will be more secured. Here we will place all the lot of restriction. For example, IP based restrictions. The application layers can take call only from this particular IP. No other IP is allowed. If any request come from any other IP, the firewall will not allow. It should be a known IP. This is called the IP whitelisting, IP number whitelisting, right? We will say we will mention this is a secured IP, and then we will allow only the corresponding person. So this is about the DMZ and keeping the infrastructure. So we discussed different components. So here we discussed about firewall, which provides security, the router, which routes the call to other apps or other servers through other firewalls. All these are nothing but an objects in a network. right? These are nothing but objects. And then next, any questions in this DMZ? Okay, let's move. If any questions, let us discuss about that in detail. This is about a physical as well as virtual server. As we discussed earlier, the resources are provisioned for in a single application, for a single operating system and application in a standalone server, physical server. In a virtual environment, we have the resources here. There is a separate special software called VM kernel. This will allocate, this will create, this will, this will, so, Anna, I'm able to hear your voice, Anna.
Yes, no problem, no problem.
Okay, sorry. So this particular, the virtual servers are nothing but, there will be one physical machine that is called host machine, and we will provide multiple virtual machines on top of that. Each virtual machines will have their own operating system. In my house, from where I'm projecting this presentation, right? So in this machine, I have two different virtual boxes with Linux operating system, right? So my host is Windows. On top of that, I have kept another layer, and on top of that, I have kept a couple of boxes, couple of servers, Linux servers. So we can mimic a network environment here. So all the available the resources like a 46 GB of RAM would be shared with all these machines. Similarly, CPU and similarly the storage. And I have mentioned the differences, and this is how it will look like. The right bottom, you can see the VM will manage the binaries, and libraries are nothing but you can think about our runtimes, Java runtime or .NET runtime on top of operating system. And on top of runtimes, we have applications running. This is the host OS. It's nothing but our physical machines operating system. On top of that, we'll have hypervisor. Hypervisor is nothing but VMware, or normally in Windows Word, we will say Windows hypervisor. So this is an architecture. And this is about how it will look like in the data center. We have rack servers and we have blade servers, two different servers. Rack servers, just compare these two. Rack server will have all the components in it. It will act as a standalone standalone system. Okay, but when we have the blade server will have only the processor and memory, and rest the storage would be managed by something called NAS or SAN. We'll say storage area network or network associated storage. So there will be a separate storage will be there, and here also in rack server also we'll have a storage separately, but all the other components will be there. For example, any graphics related component and all those things will be here. But in the blade server, we will not have all those things. We need to have a separate environment for that. And the advantage here is, if you see in the place of 3 rack servers, we can have 8 or 9 blade servers. Blade servers are plug and play kind of thing. Just we can pull out and we can pull in. We can push in, right? It will be very easy kind of a plug and play mechanism. It will easily connect with the network and all those things. So this is about how it look like, and then we'll have this is how the modern data centers look like. This data center is under the ocean, under the sea, right? Around 60 to 100 meters. Microsoft a big tube here. This person is the below diagram. You can see this person is standing within the inside the tube, and he is doing some work in the server, right? I have kept the link for this. You can read about it later. And Microsoft feels that this is a very good resilient, the data centers they have. Only a couple of slides, I believe. Anna, it's 11 o'clock. Can we move, or
Can we
do we
continue?
need to break now?
Can we continue this remaining part in the next session, please?
Sure, sure, definitely.
Okay, okay, right.
Definitely we can. Okay. Yeah, thank you. So let's continue then. Yep. Thank you.
Any questions? Any questions?
Yeah,
from the
yeah,
participants?
please. I expect questions at least physical and virtual environment. Any question with respect to buying? Any questions whether we can have a 3-tier architecture in a single physical machine with the given architecture here? We have a 3 physical machine. Can we have a 3-tier application this? Any questions like that? Or I'll ask a question, anybody can answer. Can we have a 3-tier architecture deployment model in this, please? Can anybody?
Participants can unmute their mic.
Fine.
Okay.
Okay, fine. Thanks, Anna. Thank you. Let's break now.
Right.
Yep.
Right. So now we are at the end of the technical session 1 of day 5. So I feel immense proud in concluding the technical session 1 of day 5. It has covered and touched so many key issues in application and enterprise architecture. So with this, we will end the technical session 1 and we will resume for technical session 2 shortly by 11:25. Thank you for your active participation and patient care. Thank you. Dear Parasuraman,
Yes, Anna. Yes, Anna.
Shall we break?
I'm here. Sure. So should I log off and log in again, or shall I keep it?
Okay, you have to remain in login. Then we will resume our session at 11:25. Okay.
Sure. Okay.
Right.
Thank you.
Thank you.